Okay, so real quick, let's go back to the reading. So the people that need to watch the video will see that. We know that you can have an infinite geometric series because it's going where you keep adding all the way to the very end, to infinity. Some of them will actually get smaller and smaller and smaller, and if they get smaller and smaller, they will be convergent, and they'll converge to 0 or one particular number. Some get bigger and bigger and bigger and bigger, which means they're going off to infinity. Sometimes they go to negative infinity. And if they get bigger and bigger and bigger and bigger, then it's divergent. There's no answer. Infinity is the answer, and that's not a good answer, okay? We know that if we are going to do a geometric, it has to be geometric, arithmetic just get bigger and bigger and bigger. But to do it, r's got to be less than 1. You got to be multiplying so they get smaller and smaller and smaller, right? It's got to get smaller and smaller and smaller for it to disappear, right? So, if we know that, let's take a look at a few things. So, first of all, if it is a sum, s to infinity, if it is a sum to infinity, we just use this really easy formula. But we have to remember, it's got to get smaller and smaller and smaller so that the last piece you add is nothing. You can put it all together and get an answer, right? If it gets bigger and bigger and bigger and bigger, it's going to go off to infinity. It's divergent. So r must be less than 1, okay? So now, think about this. 1/2 plus 1/4 plus 1/8 plus 1/16. Okay, sum 1. First sum is 1/2, right? That's the first sum. Then 1/2 plus 1/4, that's going to be 3/4, right? So 3/4 is right about there. Then if you add 1/8, you get 7/8 is right about there. Then if you add 1/16, you get 15/16. But you can see this sum is slowly but surely getting closer and closer to the value of 1. Okay? If I did this right, it's getting closer and closer to the value of 1. It'll never get to 1 until you get to infinity. But today, let's pretend and go to infinity. Let's just say it's possible to get to infinity, okay? So today, we're going to look at, so these are called partial sums. My 1/2, my 3/4, my 7/8, these are partial sums. But if you keep adding, this thing's going to go and get closer and closer to 1. So this one does have a limit. It has a limit, and its limit is equal to 1, okay? Now, I love this one. I showed you this one already, and we'll do it again. We can prove it. We can prove that this is 1 by 1. We already know the answer for area. We know the area answer is already going to be 1, right? So if we take 1/2 the square, we add it to 1/4 the square, we add to the 1/8 of the square, we add to the 16th of the square, we add it to the 32nd square, we add to the 1/64th, and so forth, and so on, and so on, and so on, and so on, until we add the very last one. It's like 1/2 plus 1/4 plus 1/8 plus 1/16th all the way to infinity.
I can't see it.
Oh, thank you, Katie. We know, I already know the answer. The answer is 1, but let's use our formula so we can prove it, okay? So our formula, easy formula, s of infinity, right? We're going to use this formula right there, okay? Is equal to a1 over 1 minus r, okay? So what's the multiplier in all this? What do you see? What's the multiplier? What's our multiplier? What's our multiplier? 0.5 or 1/2. Everybody agree with that? 1/2. Okay. So I know my r is 1/2 because I'm taking half of it, half of it, half of it. So I'm going to go ahead and put my numbers in. It's going to equal a1, which is my first term. a1 is 1/2. All over 1 minus my multiplier, which is 1/2. I'll get 1/2 over 1/2, which is 1. So if we add all these partial sums up, it goes to 1. But we know from the picture really shows it. We know all those pieces do add up to 1. Cool. Okay. Example 2. Is it, first of all, convergent or divergent? What do you see? What's it doing? Is it getting smaller and smaller and smaller?
Yeah.
So it's going to converge, isn't it? It's definitely going to converge because it's getting smaller and smaller and smaller and smaller. What do you think it's going to converge to? What do you think it's going to converge to? Dot, 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 dot. Eventually, don't you think it's going to get to 0? If you could, because it's getting smaller and smaller and smaller. If you could get to infinity, right? Dot, 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 dot. Do you agree it's going to eventually go to 0? But then if we could take all those pieces and add them up. So we get 5 plus 4, that's a 9, plus this one. If you take all those pieces, and the last piece you add is 0, it should add up to something. Well, let's use our formula. Let's use S of infinity is equal to A1 over 1 minus R, right? The first term is 5, 1 minus, but I don't know what R is, but yesterday I showed you how you could find R. If you don't know R, you can always figure it out by taking the second one divided by the first one, right? So yesterday, okay, if we can't find R, question mark, it's just the second one divided by the first one, because I don't know what R is, but it's probably going to be 4 over 5 or 0.8, right? So, if I were to take 5 divided by 0.2, should be, let's see, if I go 5 divided by 1 minus 0.8, oops, hold on, 1 minus 0.8, I get an answer of 25. So all those pieces will eventually add up to 25, okay? All right, you're going to like example 3. You're going to like example 3 really well because you can't do it. You guys agree? Yeah, you can't do it. You guys agree? Yeah, it gets bigger and bigger. So we know it's divergent, right? Because it goes to infinity. Goes to infinity. And we already know the answer. The sum is equal to infinity. So no formula, no nothing. We're done, right? That makes sense. It won't add up to anything because it just gets so big, it goes to infinity. Okay? Easy day, isn't it? You guys okay? I mean, I say it's an easy day, and some kids, well, it's easy for you, Mr. Davis. You have a degree in math. Yeah, but I really think this is easy for you, right? Okay? Turn the page. Okay. All right, now, find the fraction that represents the repeating decimal. 0.45, 45, 45, 45. So it is the same thing as 0.0. It's the same thing as 0.45 plus 0.0045 plus 0.00045 plus 0.00. You got the idea? 1, 2, 3, 4, 5, 6, 4, 5, so forth and so on. Okay? So it will become some fraction. It really will. You know it's going to go to 0. So if you were to add all these pieces up, you should get an answer, right? So let's use our formula. Use our S of infinity is equal to my A1. A1's 0.45, right? Or I'll put it up here. S of infinity, A1 over 1 minus R. There's our formula, okay? 1 minus, what's our multiplier? What's our multiplier? What's 0.01, isn't it? Isn't that our multiplier? Okay. Which is 0.45 over 0.99, which is 45 over 99. Now, I'm going to tell you a little secret, which is, of course, always works. Anytime you have a repeating decimal, it's always over 9. Any repeating decimal is always over 9. Since this one has 2 spaces, it's over 9 Does that make sense? You know 0.6 repeating is the same thing as 6 over 9, which is 2/3, right? You knew that one, right? So any repeating decimal is always over 9. If it repeats twice, it's over 9. If it repeats in 3 spaces, over 9. It always works that way. Isn't that cool?
Isn't that 5 9?
Which does it? I don't think that reduces. Hold on, I'll try it. 45, 99. You are 5/11s.
Oh, you're saying that 5 11.
Thanks, Claire.
Wait.
It reduced. I just reduced it on my calculator because I can divide them both by 9 to reduce it, right? Thanks, Claire. Thank you. Okay. Now, number 5. Okay. So number 5 to infinity. So first of all, let me ask you an easy question. What is R in example 5? It is 2/5. It is 2/5. What's A1? 2/5 also. Because if you plug in 1, you guys agree? So A1 is also 2/5. Will it diverge or converge? Will it diverge or converge? It will converge because R is less than 1. So it's going to get smaller and smaller. I mean, anytime you multiply something by a fraction less than 1, it's going to get smaller and smaller and smaller. So let's use our formula. A1, so S of infinity is equal to A1, which is 2/5, over 1 minus 2/5, right? Well, that's 2/5 divided by 3/5. I'm just doing some fractions here, right? Invert multiply. 2/5 times 5/3, right? Just doing some fraction, fancy fractions, right? Cancel, cancel, and I get 2/3 as an answer. Cool. How about example 6? How about example 6?
It's bigger than 1.
Nice. So what do we say? It's divergent. End of story. Right? Because Avi's right. If you multiply by a fraction bigger than 1, it's just going to get bigger. And then bigger. And then bigger. And then bigger and bigger and bigger and bigger. So it goes to infinity. Divergent. Done. Okay. Example 7 is a real problem. When the doctor gives you medicine, he or she is not trying to get your bloodstream to have this much in it, but an accumulation. Because when you take your first medicine, it will decay. But when you take your second pill, you got a little bit left of the first, and then you take another dose. Does that make sense? So like for instance, the first term would be 500, okay? Now, the second term is going to be, well, the 500, take 35% of that. So 500 times 0.35. I get 175. That's all that's left, but then, bam, you take the next pill, right? So now, your dosage in your bloodstream is 675. So then A3, we take 35% of that, right? Which is takes 35% of what's there. So I take 35% of that times 0.35. Boom, and I get 236.25. But boom, you take another pill, right? So the doctor is trying to get this medication to level off at a certain level. Now the doctor doesn't do the math. They've got smart mathematicians that give them a chart. They look it up on the computer and they say, okay, Bill Davies weighs 150 pounds. So how much medicine should we get him so that his dosage of 500 actually is a level of, well, let's find out. What should my dosage be in my bloodstream if I keep taking this pill every day? And I do take a pill every day. Lucky me. So I take 20 milligrams of statin. So anyway, let's do this. So it's got to be an infinity problem. Because I have been taking this medicine now for 12 years. I've been taking this medicine. So unless I miss a dosage, it has leveled off to a certain spot, right? So it's an S of infinity problem, isn't it? I've been doing it for 12 years. Feels like infinity, okay? So what's my first dosage? 500. 1 minus 0.35, right? So if I use my calculator, 500 divided by parentheses, 1 minus 0.35, it levels off to about 769.23 milligrams of, say, atorvastatin, because that's what I have to take every day. Kind of cool, huh? Yeah. So, it's 1, 2, 3, 4, 5, 6, 7. Oh, 8 problems. I'm killing you, aren't I? Killing you. 8 problems, and we've got like, oh my gosh, we've got 40 minutes.
We have the big test tomorrow.
Wow. So let's think about that. Let's do some math. 40 minutes, 8 problems. 40 minutes. We have 5 minutes a problem, don't we? We can do it. Yeah. I would love to stamp here. I can't find my Apple stamp, but I'll give you a smiley face. How's that sound? Hopefully my Apple's gonna reappear, huh?
DJ plug.
Yes. Yes.
Look at those muscles. Yeah. What? I'm doing a chin up. I can't do a pull-up.
Sure.
I'm so much better than my mom.
Hold on.
You are? What?
How'd that happen? She doesn't go outside?
Okay, look at me. And then...
She doesn't go outside.
I know.
Sweat it off. Clean the bathroom, whatever, right?
big tie. I know
Oh,
that's
this
right.
one have the die.
That's the one. Can I go work on this outside?
Yeah.
Like,
What is you guys working? Oh, am I still recording? I'm still recording. Oh my goodness gracious, you guys.
baby.